All right, so we are going to be adding and subtracting scientific notation, or numbers in scientific notation. Okay, let's start with an example so we have something to work with. We're going to start with 3.4 times 10 to the third. We're going to add that with 2.1 times 10 to the second. Okay, now, step number one. We have to find a common exponent. Just like in math, you have to find a common denominator for adding fractions. You have to find a common exponent when adding numbers in scientific notation. So in this case, we are going to change this 2 into a 3. All right, and the way we do that, we're going to move our decimal to the left 1, and that's going to increase our exponent. Okay, so moving decimal left equals an increase, and then moving, we'll look at an example where we move the decimal to the right, and that's going to decrease the exponent. Okay, so now that we've found the common exponent, we have 3.4 times 10 to the third plus 0.21 times 10 to the third. Okay. Step number 2. We are going to add the base numbers. When we add the base numbers, we have 3.4 plus 0.21. Okay, and we're going to follow our significant figure rules for adding and subtracting. Okay, so follow sig fig rules for adding and subtracting. Okay, so we're going to line it up, make our little make our line down to the right of the number with the fewest decimal places, and then we're going to add it. So 3.61. There's our number that we have to round. There's the number we're rounding, or we're looking to see whether it goes up or stays the same. And because it's a 1, we're going to stay the same. So our base number here is going to be 3.6. Okay. Now, step number 3. Right, we are going to bring down the exponent. All right, so if you remember that we changed our exponent in both numbers to 3. So 3.6 is our base number, and our exponent is 3. So our answer is 3.6 times 10 to the third. Okay, and again, significant figure rules. When we're adding and subtracting, this number had 1 decimal place, and this number had 2 decimal places, so, or 2 places after the decimal. So our answer can only have 1. Okay. Let's look at the same number, because a lot of people ask, well, what if you move the other number to a 2? Okay. So if we move the other number to a 2, we'll do that same example again and move it to a 2. All right, so we have 3.4 times 10 to the third plus 2.1 times 10 to the second. Okay, and we're going to move, instead of making the decimal a 3, we're going to move that decimal, making the exponent a 3, we're going to make it a 2. All right, so we're going to change this number right here. All right, so to make it a 2, we need to have our exponent go down. So if we look at that rule that I wrote up here earlier, we want our exponent to decrease, okay? So we're going to move our decimal to the right. All right, so 3.4 becomes 34. So we end up with 34 times 10 to the second plus 2.1 times 10 to the second, okay? Again, add the numbers. 34, 2.1. Okay, again, significant figure rules apply. We end up with 36.1. Again, do your rounding, and you end up with a base number of 36. If we bring our exponent down, we end up with 36 times 10 to the second. The problem with this answer is that 36 is not an appropriate base number for scientific notation because it has to be between 1 and 9.9. Okay, so there's our decimal in 36. And to get that to get that base number between 1 and 9.9, we're going to move it to the left one. Okay, and when we move our decimal to the left, we increase our exponent. So we end up with 3.6 times 10 to the third, which is the exact same number as we got the first time. So it doesn't matter if you move one decimal up or the other decimal down. It really doesn't make any difference. Mathematically, it's all going to come out the same. Okay. So let's do an example. We'll do a couple examples here. We'll go 8.4 times 10 to the fourth plus, let's go minus. Let's subtract these. Minus 3.2 times 10 to the third. Okay. Again, it doesn't matter which one you do. We're just going to change this exponent to a 4. All right. So changing that exponent to a 4, we're going to move our decimal to the left one. So we end up with 8.4 minus 0.32. Okay, and when we do our math, we get 8.08. Okay, we're going to round the 0. Okay, we round across that red line. We're going to round the 0 and look to the 8, and that's going to tell us that our base number is 8.1. Bring down our exponent. 8.1 times 10 to the fourth is our answer. Okay, let's do another example. Let's do another addition example. You have 1.5 times 10 to the fourth plus 3.3 times 10 to the third. Okay, now again, I am going to move this 3 to a 4, this exponent from a 3 to a 4, and I always just choose to do the same thing. Just raise an exponent. That way, you're always doing the same thing. You're always moving a decimal to the left. Okay, so we're going to move this decimal to the left one place because we have to increase our exponent one place or one number. All right, so we end up with 1.5 plus 0.33. Put our red line down for our significant figure rule. Add them up. 1.83. We're going to round the 8. Look to the 3. And the 3 tells the 8 to stay the same. So it's 1.8. Sorry, 1.8 times 10. And then we bring down our exponent of 4. Okay, because that's what we had changed both of the exponents to. And our answer here is 1.8 times 10 to the fourth. Okay. Again, I always like to do the same thing. I always like to just increase the exponent. It makes it so much easier on me because I don't have to worry about, hey, am I lowering this time, which means I have to move the decimal to the right. No, I'm always raising one of the exponents, which means I'm always moving my decimal place to the left. And I think that'll probably help if you just choose one and move on. That is adding and subtracting numbers in scientific notation.